Okay, so last week we were talking about transformations. There are 4 of them: rotation, reflection, translation, dilation. Rotate means to turn, translate means to slide, reflection means to flip, and those 3 are rigid motions. Remember, they preserve size and shape. Translations also create parallel lines. They're the only transformation that does create parallel lines. Also, on Thursday, we learned about perpendicular bisectors. So, as a review, do you remember what a perpendicular bisector does?
Intersects a line. Have the same.
And creates 2.
Yeah.
Same. 2 equal parts, and then the perpendicular part. What type of angles do they form? If I draw it, that might help you. Oh, I forgot. You weren't here on Friday, were you? I just videotaped to the remote learners. Okay, so say you have a line. A, B, and then here is the perpendicular bisector, so it creates a right angle, and then it also cuts that line into 2 equal parts, like you said, and it actually goes through the midpoint, so C would be a midpoint. This is all review though, and it's been like 4 days now, so it might be fuzzy. But today, we are going to do lesson 6 in unit 2. It's on congruency and rigid motions. So we're gonna go over the definition of congruency. We're gonna learn which transformations create congruency. So rigid motions, you already know those 3. And then we're gonna learn how to describe transformations that were performed when we're given 2 triangles. So, I'm gonna pull up the lesson. I don't remember what page this is because I know that everything got copied out of order. But it should look like this. Congruency, rigid motions, lesson 6. Perfect. All right, so we're on page 26. I'm just gonna zoom out a little bit because this is pretty zoomed in. Okay, so it says, Casey, do you remember any of this? Congruency? I taught Casey, my homeroom student, already went through this. Alright, so you've learned in the past that 2 geometric shapes are congruent if they have the same size and shape. So we use a symbol equal sign with a tilde over it, or the squiggly line over it, to stand for congruence because it combines the equal sign, which means equal or same size, with the similarity symbol, which is the tilde, and that indicates the same shape. So that's where we get congruency from, same size, same shape. In exercise 1, the 2 triangles pictured below are congruent. Alright, so use tracing paper to verify what vertices correspond to each other on the 2 triangles. Make a formal statement about the congruency of the 2 triangles. Okay, so what I want you to do, Casey, is I want you to trace triangle ABC and label the vertices, or the angles A, B, and C. And let me know if you need any tools. I really like our new lines.
I know.
Aren't they fancy, Casey? You barely see them. Alright, so beautiful. Now line it up so that it lies perfectly on top of the other triangle. You might need to flip the paper. Ooh, there we go. Okay, so can you leave it like that and help me out with this? So I'm gonna write that triangle A, B, C is congruent to, and then when you're done. No, go ahead, you can erase. When you flipped over your paper, what angle did A lie on top of?
E.
E? Okay, so I'm gonna write then it's congruent to triangle E. And then what did B lie on top of?
D.
D. And then I'm gonna assume that C fell on top of F. Okay, so there are two important things that I want to point out with this. I wrote it in the order A was equal of the order that the angles were congruent. So you told me that A was equal to E, so I wrote A first and then E first. You told me that B was equal to D, so that's why I wrote B second, D second. And then you told me that C was equal to F, so that's why I wrote C third and F third. Also with the diagram, I put arcs. You told me that A was congruent to E, so I have one arc for those. You told me that B was congruent to D, so I put two arcs for those. And then C was congruent to F, so I put three arcs for those. When you do those arc marks, it shows you by looking at the diagrams which angles are congruent. Also, when you write your congruency statement in this order, it tells you that A is equal to E, B is equal to D, C is equal to F. These are all going to be helpful clues when you start to do proofs. Alright, so the definition of same size and same shape has worked fine up until this point, but now we're going to introduce a formal definition of congruence. Okay, so I'm going to erase this. Congruence. Here's a formal definition. Two figures in a plane are congruent if a sequence of rigid motions can be found that make two figures coincide. So I've used the phrase coincide a lot. It means they lie on top of each other. Do you want to highlight that or no? It's up to you. No? Okay. So when you flipped over your tracing paper and you made the triangle fall on top of each other, that was coincide. We call this a sequence of rigid motions of congruence. Okay, so congruence just means same size, same shape. Alright, I can remember that. Number 2. Why does this formal definition of congruence make sense when considering the middle school definition of congruent as same size, same shape? Okay, so it's asking why does congruent, which means coincide, which means lie on top of each other, mean same size, same shape? So why do they mean the same thing? Or why do they, I guess why do they have to mean the same thing? Would something be able to lie on top of itself if they were a different size and shape? No, good. Thanks for shaking your head. Alright, so I'm going to write something like that down. I'm going to more or less write why it wouldn't work. Okay, so I'm going to write congruent means coincide, parentheses, lie exactly on top of each other. So congruent means coincide, which means to lie exactly on top of each other. Semicolon. This would only be possible if the figures were the same size and shape. So again, I'm just reinforcing the fact that if a figure is not the same size and same shape, there's no way it could fall on top of it itself. That's like trying to put a circle on top of a square. You know, it just wouldn't match up perfectly. And I'm really sorry if my tenses are flipping back and forth. I'm not an English teacher. Alright, next up. In this lesson, we'll be given two congruent shapes and we'll try to identify the rigid motions that map one figure on top of the other so they coincide. So again, we're going to try to figure out if a reflection, rotation, and translation was used or in which order. So the figures fell on top of each other. Alright. And actually last week we did the opposite. We created the transformation so they fell on top of each other, and now we're going to figure out what happens. We're going to start easy. So in exercise 3, in the following diagram, it is known that triangle ABC is congruent to triangle DBC. So just remember that that means that angle A is congruent to angle D. So I'm going to put one arc at A, one arc at D. It's telling me that B is congruent to B. Now you'll notice that the top B is congruent to the bottom B. So two arcs. And C is congruent to C. Again, that's the top C is congruent to the bottom C. So three arcs and three arcs. This one looks pretty easy. So it says describe a rigid motion transformation that would map triangle ABC on top of triangle DBC. Use tracing paper to help you verify and explain where each of the vertices on ABC gets mapped onto and why. Oh, good job, Casey. I already see you tracing it. That's awesome. Oh, good job. All right, so notice that you flipped your paper over. So what transformation is that?
Reflection.
Very good. Reflection over what line? Very good. Okay, so let's see here. Reflection over line BC. Would cause then we have to write what vertice falls on which vertice. So it would cause A to coincide. Bye, Casey. Have a good day. We'll come in and check on you and stuff. So A is going to coincide on D. Let's see here, B to coincide on B, and C to coincide on C. Great job, good job. All right, next exercise, here we go. Exercise 4. So it says in the diagram below, triangle, I'm gonna sound like a broken record. TRS is congruent to triangle TUV. Okay, so I'm first just gonna match up my angles. So I see that T is congruent to T, so I'm gonna put one arc at T, one arc at T. Then I see R is congruent to U. Two arcs. And S is congruent to V, so three arcs. Okay, Alright, give a rigid motion that maps triangle TUV onto TRS. Use tracing paper to verify your transformation. Casey, you're already on a roll. No, you can't leave. I'm just kidding. I'm just kidding. Thanks for doing that, Mr. John. Sometimes a John is here. What are you thinking? What if you turn it?
Turn what?
Turn the tracing paper. Maybe 180 degrees? Did it work? Yes. Alright, cool. So, what transformation did we just try?
Rotation.
Rotation. Around what angle? Like, where did you keep the paper the same?
T.
Very good. So rotation about T. And how many degrees did you rotate it?
180.
Awesome, right? Rotation about T, 180 degrees. Will cause, and then we gotta rewrite all this stuff again. Will cause. Here we go. T to coincide to T. Has a teacher ever used quotation marks so you don't have to rewrite things before in a class for you? No? Okay, so you can write, if you just peek up here real quick, I did a quotation mark for to, a quotation mark for coincide. That means whatever I wrote above that, just bring right down so I don't have to rewrite it. So U to coincide, R and V to coincide S. Fabulous. So then it says, these can become more difficult when multiple rigid motions are used to map one figure on another. There will be at most a sequence of 3 rigid motions. So you can sometimes have problems that do a reflection, rotation, and translation. Most of the time though, they're just 2, but if it's like the last question on the Regents exam, it might have you do 3. I'm not worried though for you because I feel confident. You seem really good at this stuff. So exercise 5 says, give a sequence of transformations that would map right triangle MNQ to the right triangle WXY. Be as specific as possible in your description of the transformations. Alright, now before we go any farther, Casey, I'm going to do what I've been doing for the last 2 problems. I'm going to match up the angle. So M was written first, and so is W, so that means that M is equal to W. And actually you can tell by looking at the diagram because they both have right angles. Then since N was written second and X was written second, that means that N is equal to X. So I'll do one arc. And then Q is equal to Y because they're both written third, so I'll do 2 arcs. 2 arcs. Okay, so I have to figure out, and I say I, but I kind of mean you because you have the piece of paper. What transformations occurred to get M and Q to fall or coincide on WXY? There are several different orders you can do this in, and you can use tracing paper to help you verify. Now I feel like we're definitely gonna have to do a reflection at some point because I noticed that M is on the left side when we're given the triangle and then it needs to end up on the right side. So I feel like there's definitely gonna have to be a reflection. And I also noticed that the paper is, the triangle's like definitely moved over to the right. So what are you thinking? Okay, do me a favor. Can you put the triangle, the tracing paper on top of the original triangle? Alright, let's try to, what if you slid it to the right so that N just touches this line? And then flip it. Does it fall on top? And then what if we turn it some direction? Oh, did that work? Oh, yeah. Okay, so what did we do? We did a translation to the right. Then we did a reflection over, line WX, and then what way did you just turn it? I'm sorry, I wasn't paying attention. Was it clockwise or counterclockwise? Okay, well, we'll just write it down. Okay, so first translation to the right. And then we did a reflection over line XY. And then we did a rotation. Good job. Okay, one last problem. You're flying through today. Alright, sometimes it's easiest to quantify or describe the transformations when they are on the coordinate plane, so when we're using graph paper. I would actually agree with that because you can tell people how many units to move. So like move 5 units to the right, move 2 units up, reflect over this. And it's like very set in stone and easy to see. So number 6, we're gonna describe a sequence of transformations that would map triangle ABC onto triangle DEF and explain why these triangles are congruent. So explain why they coincide. And again, when we're done, we're gonna have A be congruent to D because A was written first and D was written first, so 1 arc, 1 arc. B is gonna be congruent to E because B is written second and E is written second, so 2 arcs, 2 arcs. And C will be congruent to F because they're written third, so 3 arcs. Alright, Casey. I'm gonna write down the original coordinates for ABC vertically like we have been doing last week. And then we're gonna make some arrows and stuff. So I'm gonna write down that A, let's see here, here's the origin, so I have to move to the left 8 units, so -8, and down -2, so -8, -2. B is to the left 5, so -5, down 8, so -8, and C is to the left 4, so -4, up 1. And then I think we can do this in 2 transformations. I think in 2 transformations we can get ABC to fall on top of triangle DEF. Ideas on what you want to do first.
Translation.
You want to do a what?
No, I don't know.
How about, can we get C to be the same height as F? Can I move this triangle up? How many units up would I have to move it?
6.
1, 2, 3, 4, 5, 6. Okay, yeah, so let's at least move it 6 units up. Now, do you want to move it over to the right at all? How many units to the right do you want to move it?
2.
2? Ooh, I like that because then it's the same distance from the y-axis. You are smart. Okay, so that was, so we're gonna do a transformation. And let's see here, we're moving to the right 2, so a subscript of 2. And we moved up 6, so 2 comma 6. So I'm gonna add 2 to my x values and 6 to my y values, and then I'm gonna get my new points. So 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6. And then I'm gonna connect these. And I'm gonna write down my new coordinates. Let's see here. A is to the left 6, so -6, up 4. B is to the left 3, down 2, and C is to the left 2, up 7. Alright, then we just gotta figure out that last transformation so that C prime will fall on top of F, A prime will fall on top of D, and B prime will fall on top of E. So how am I gonna get that triangle to fall on top of the right triangle?
Reflection.
Reflection, over where?
The wire.
Very good. Oh my gosh, Casey, I love teaching you. You are so smart. So lowercase r is reflection, subscript y-axis. So I'm gonna reflect over this line. And that will definitely work. C is 2 units away from the y-axis, so when I reflect it, it falls on up, which is perfect. So that would be 2, 7. When I reflect B prime over the y-axis, it's 3 units away. E is 3 units away, so that's perfect. And when I reflect D, it is 6 units away. I'm sorry, A prime, which then gives us D. So perfect. So all we have to do is just answer the last part of the question, which says, explain why the triangles are congruent. Well, congruent means not only same size, same shape, but it means to, what was the other C word? Coincide. Very good. So that's all we have to write. So I'm gonna write down a triangle. ABC is congruent, so equal sign with a tilde over it, to triangle DEF because B\C. The triangles, I'm using the symbol for that, The triangles coincide. And they coincide after a translation and a reflection, but I don't have to write that because I showed all of my work. I wrote what the translation was and I wrote what the reflection was. So great job. All right, as a closing for today, coincide means to what? The other C word is? Good, falls on top of it itself, yep, and then congruent, right? Yes, awesome.